Hi folks, we're going to take a look at this question for the assignment. So they want us to find two values such that this equation is satisfied. And the first thing I notice is that I've got two different trig ratios on either side and that they're negatives of each other. So because the trig ratios are different, that should make you think of the correlated angle identities. Okay, so if you take a look at your formula sheet, the one you'll have access to, you'll notice that there's no identities for secant and cosecant, even though they do exist. If you check the note, you'll see that all of them are present. But we can use this to still help us out, because remember that secant is just 1 over cosine, cosecant is just 1 over sine. And so whatever relationship there is between cosine and sine will also exist between secant and cosecant. Okay, so essentially I'm just looking for an identity where a cosine value is the negative of a sine value. Okay, and we see a couple of options here. So we see in C, cos of 3 pi over 2 minus theta is negative sine theta. So what will also be true, since if you just take the reciprocal of both sides, is that secant of 3 pi over 2 minus theta is going to be equal to the negative cosecant of theta. And the other one, of course, is this one here with pi over 2 plus theta. And that's actually the one that I'm going to start off with. Okay? So what we know is that the secant of pi over 2 plus some angle is equal to the negative of the cosecant of that angle theta. Okay, so this is going to help me find one answer to my equation. And what we see here is that the structure of both of these equations are identical. I've got the secant of some input on the left-hand side equaling the negative of the cosecant of some other input on the other side. So essentially, all I'm going to do is equate these inputs. Okay, the functions that are being applied to these inputs are the same already on both sides. So here, what I'm able to write is that 3a minus pi over 4 is going to be equal to pi over 2 plus theta. But what is theta equal to? It's just 4 pi minus pi, 4a minus pi over 4. All right. So again, all I'm doing is I'm equating the inputs on either side of the equation because the structure of the equation is exactly the same. So this angle here can be written as pi over 2 plus, okay, that angle there. And so now what I'm left with is an equation that only involves the inputs and that only includes the variable a, so we can solve for that. So I'll bring the 3a to the other side, so 4a minus 3a is a. Okay, and so here I had a negative pi over 4. Here I've got another pi over 4 that I'm going to be adding. Okay, so those just cancel out, so I'm just left with negative pi over 2. So one of my answers is negative pi over 2. Okay, now what you could always do is take negative pi over 2, stick it into the left-hand side of the equation, stick it into the right-hand side of the equation, and confirm that the two sides are indeed equal. Okay, that's how you could check your answer. All right, my second option is going to be that other relationship between cosine and negative sine, or secant and negative cosecant. That's going to be that the secant of 3 pi over 2 minus theta is equal to negative cosecant of theta. Okay, and again now, the input of the secant, 3a minus 4, is going to be equal to 3 pi over 2 minus theta. So 3a minus pi over 4 is going to be equal to 3 pi over 2 minus theta, but the theta, again, is just equal to 4a minus pi over 4. Now, a little algebra thing I'd like to bring up. You notice here that I put this 4a minus pi over 4 in brackets, even though I was adding it. It actually made no difference to put it in brackets or not. But again, what I do is I figure if I always put something that I'm substituting, because I'm substituting this theta with 4a minus pi over 4, I just always put in brackets, so when it is important, I don't forget, because here it certainly is important. If I didn't put the brackets, I would not realize that that should be plus pi over 4, because this negative is distributed to both terms. Okay, so let's solve this. So this minus 4a is going to go to the other side, so I'm going to end up with 7a. And what do we have here? So I'm going to put everything over 4. Okay, so this 3 pi over 2, I'll just put it as 6 pi over 4, plus pi over 4. And then this negative pi over 4, bring it to the other side. There's another plus pi over 4. So here, what do we have? We have 7a is equal to 6, 7, 8 pi over 4, which is just 2 pi. And so a is also equal to 2 pi over 7. And there's a second solution for this equation. Okay? So, step number 1, identify that this is going to be one of your correlated angle identities that you're going to use. Figure out which ones are usable in this circumstance here. So secant is equal to negative cosecant at the exact same angles where cosine is equal to the negative of sine. So that's why I use these two identities, and that allows me to find two answers to this equation. Now you might want to think about how you might find a third or fourth or fifth answer to this equation, because I suspect that there's probably infinitely many solutions given that these are periodic functions. Okay, that's it for this one.